Let's take a look at this first example of dilation with respect to the origin. Now, of course, the origin is where the x and y axis meet, 0, 0. And so what we're going to do is we're going to start off with our pre-image, our original shape. So we've got the vertices of some triangle ABC, and here's the coordinates. So let's quickly graph these. So across 1 up to 3, there's A. Across to 2 up to 3, there's B. And across to 2 up to 1, there's C. So I join those together. There's my triangle. And so what we're going to do is we're going to do a dilation by a scale factor of 2. Now, first off, what that tells me is that since this is larger than 1, it means we're doing an enlargement. In other words, scale factor of 2 means we're going to make this twice as big with respect to the origin. Now, again, with respect to the origin just means that instead of going from the origin to here, we're going to go out twice as far. We're going to do that for this one, and we're going to do that for C as well. So imagine it's almost like a flashlight shining on some triangle, and then behind it, somewhere twice as far away, that shadow is going to hit the wall. Now, to find this mathematically, though, of course, what we're going to do is, like was said earlier in the presentation, is we're going to take the scale factor of 2, and we're just going to multiply everything by it. So in other words, I'm going to do times 2. And so A prime is going to end up at the location 2, 6. I just doubled both my coordinates. Same thing here for B. I'm going to multiply everything by 2, get B prime, which will be 4, 6. And multiply this one by 2, and I'll get C prime at 4, 2. So 2, 6 is right here. That's A prime. B prime would be at 4, 6, which would be right here. And C prime would be at 4, 2. All right, so if I've done this correctly, what I should get is a version of this triangle twice as large. And I can see again those projection lines. If I match up A and A prime, they lead back to the origin. If I match up B and B prime, they lead back to the origin. And if I match up C and C prime, they lead back to the origin. All right, so that's how we incorporate the coordinate system with our understanding of dilation.